Here is a communication question, and let's try to understand and analyze how intersecting planes and their normals are related. So we have three different scenarios here. So the first one here is three different planes intersecting in a line, right? So they are all intersecting in one line. So this is a consistent, right? So it has unique solution. So this situation is consistent and it has unique solution. Now what is so special about these normals? So when you see the normals, let's say planes are pi 1, pi 2, pi 3, and their normals are n1, n2, and n3, right? If these are the normals for the three planes, you'll find that their scalar triple product, that means n1 dot n2 cross n3 is equal to 0. That means the normals are coplanar. So this is what you will see in this particular case when you analyze the normals. Now here's the second scenario. In this case, two planes intersect in a line. So there are three different intersecting lines, and what you notice is that lines are parallel. So all these intersecting lines are actually parallel, right? So we get three set of lines, and you see triangular prism is formed right there like this, right? So in such cases, how are the normals related? Now in this case, what you'll find is that n1 cross n2, if you do, and you find that n1 cross n2 is equals to n1 cross n3, and that is also equals to n2 cross n3. So you'll find in this case that the cross product of any two normals taken in any order will be exactly same. So the cross products are scalar multiples. So that means that all the three lines are parallel, right? So that is the scenario in this case when they intersect in three different lines. In that case, the cross product of the normals will be exactly same, right? Now here we have a different scenario. We have two overlapping planes, right? Let's say this is our pi 1, this is pi 2, and pi 3. So in that case, of course, n1 is actually equals to n2, right? And since they are parallel, they are actually scalar multiples. So I should say, so when you reduce them, you can say n1 equals to n2 equals to n3. But the important thing here, how they're different, is that pi 1 is equals to k times pi 2, but pi 1 is not equals to k times pi 3. So that is the case when the equation of the three planes are considered. Then these two equations are not exactly scalar multiples, but their normals are scalar multiples. You can write them as k also, or sometimes we factor k and write them as the lowest common set of numbers, right, which shows the direction number for the normals. So either way, so what we're trying to say here is that in this case the normals are same for all the three, but the equation of the line is not a scalar multiple as a whole, right? So remember, equation is ax plus by plus cz plus d, right, equals to 0. So that d is different for this. If you multiply the whole thing by a scalar k, for example, this whole thing, then you'll get the other equation, which will be kind of same along with that constant term, but in this case this one will not have the same constant term. So that is how they're going to be different, correct? So that is how you can relate to the intersection with the normals when three planes are being considered at the same time. I hope that helps you. Thank you.